Here are some examples of solving equations using trig identities. The first one here is we're going to move everything over to the left-hand side. Sine 2 theta minus cos theta equals 0. And then I need to get everything into the single angle formulas so that I can get my equation in terms of the same trig ratio. So I'm going to use the identity for sine 2 theta, that it's equal to 2 sine theta cos theta, and I'm just going to replace that. Now I've got an expression or an equation that I can factor. I can take cos theta out, and I'm left with 2 sine theta minus 1 equals 0. Now I can use the zero product property, and I can say that cos theta is equal to 0, or 2 sine theta minus 1 is equal to 0, which means that sine theta is equal to 1 over 2. So in my first one, cos theta, my solutions here would be equaling 0 would be pi over 2 and 3 pi over 2. And then in my second one, I know that 1 over 2 is a trig ratio from my special triangle. So I'm going to draw that trig ratio. I've got 1, 2, and root 3. This is pi over 3 and pi over 6. I also know that sine is positive. So my two solutions are going to be in these first two quadrants. I've got one solution here, which is happens to be my related acute angle. And then I've got one here, which is going to be pi, take away my related acute angle. So let's see, my related acute angle for 1 over 2 is when 1 is the opposite, 2 is the hypotenuse. So my related acute angle here is pi over 6. So that's going to mean that theta is equal to pi over 6, or equal to 5 pi over 6. The next one that I have here, I notice that they are squared on both sides. And so what I'm going to try doing here is I'm going to divide both sides by cos squared theta. So let's try that. I've got sine squared theta, divide by cos squared theta on both sides. Rewrite that. Cos squared theta, which is going to leave me 3 by itself. And now I divided both sides by cos squared theta because I noticed that sine over cos is equal to tan. So here I get tan squared theta equals 3. And then I can take the square root of both sides, and I get tan theta is plus or minus root 3, which actually goes along with the same special triangle that I had up here. So I've got tan is positive or negative, so that means that I've got the two solutions that are positive from the positive square root, but then I've also got the two solutions that are negative. So I really just need that related acute angle. Related acute angle for pi over 3, that's when it's the opposite over the adjacent. So my related acute angle has to be pi over 3. And so then my solutions are going around. I've got pi over 3. I've got 2 pi over 3. I've got 4 pi over 3. And then I've got 5 pi over 3. In this last one, I see that on my left-hand side, I've got cos 2 theta, and it's a different trig ratio than the right-hand side. So that prompts me to recognize that I'm probably going to need to use a double angle formula. And then what I'm going to choose is 1 minus 2 sine squared theta. Now I chose this one because it gets my left side and my right side in the same trig ratio. And I've done lots of work with factoring trig equations before, so I think that might help me here. So I'm going to move everything over onto the left-hand side so that it's equal to 0. Then I'm going to multiply through by -1 so that I get my first term being positive because that is easier to factor. And now I've got a trinomial in terms of sine, so I'm going to factor that expression as sine theta plus 1 and 2 sine theta minus 1 equals 0. So now I've factored my expression. Now I can use the zero product property, and I can say sine theta is equal to -1, or I can say that sine theta is equal to 1 over 2. So on the left-hand side, this is when sine theta is at a minimum. From my trig graph that I've memorized, I know that -1 happens 3/4 of the way through the sine graph. So theta is going to be equal to 3 pi over 2, 270 degrees. And then from my sine theta equals 1/2, I'm using the same special triangle over here. For sine theta to be 1/2, that's actually even the same as my first one. So I know that my related acute angle is going to be pi over 6. I know that my answers are in the first 2 quadrants. So my thetas are pi over 6. And let's see, 5 pi over 6. And those are my solutions for the last equation.